Runge-Kutte's fourth order method. We are discussing about the Runge-Kutte's fourth order method. This method is also for the same linear differential equations. Any differential equation we shall discuss can be solved by either Euler's method or the Runge-Kutte's fourth order method. The objective is same again. The difference is the results, the accuracy of the results, that is the difference. But this procedure is somehow lengthy than the Euler's method, but it provides the more exact values than the Euler's. If we do the 3 steps or the 4 steps in the Euler method, here in this Runge-Kutte's method we can get that result only single step. Let us first of all see the nature of the functions involved in this method. Here the main formula is yi plus 1 is equal to yi plus s. It may be s, it may be k in some books or some other word, so we have considered it as s. What is s? S is equal to 1 by 6 times s1 plus 2 times of s2 plus 2 times of s3 plus s4. And who are s1, s2, s3, s4? Now we write it for s1 is equal to h times f of x1 y1, and s2 is equal to h times f of x1 plus h by 2 and y1 plus s1 by 2, and s3 is equal to h into f of x1 plus h by 2 comma y1 plus s2 divided by 2, and s4 is equal to h times f of x1 plus h comma y1 plus s3. These are the formula associated with this method. Rather it is lengthy but not so typical, only simple algebraic calculations only. We shall go through these steps one by one. There may be the difference in the formulas in the certain books that we have considered the h outside the function. In some books it is introduced into the brackets, but both the procedure same. We shall follow our IGNOU booklets that is given in the IGNOU booklets, and there may be k instead of the s. Let us discuss a problem in some other way other than Euler's method. Solve the IVP. Solve IVP dy by dx is equal to x square minus y. y0 is equal to 1. Find y.2. It is another formation for the IVP. This formation may also exist into the Euler's method. Sometimes two values are asked, y.2 and find y.1. As we do this, it will be done similarly. As in the Euler's case, we followed the 3 steps. I said follow the 3 steps, but in such cases only 1 step for this and 1 step for this. No, here h is in the hidden form. Again, let us start. Here is the initial values. They are x0 is equal to 0 and y0 is equal to 1. Same manner as in the Euler's method. Now what we have to find, it is x. y.2, it is x, it is also x, and it is x0. And what is h? h is equal to x minus x0. It is a new formula for finding the h. Then according to these given conditions, h is equal to x 0.2 minus 0, that is equal to 0.2. If we consider this case, then h will be 0.1 minus 0, that is equal to 0.1. That is the difference. In the one problem, the methods are two, or the results are two for the different values of the x. Now we shall proceed for these given values. Here is the main formula for the Runge-Kuttas method. yi plus 1 is equal to yi plus s. Say put I is equal to 0, we get y1 is equal to y0 plus s, or we can say y1 is equal to 1 plus s. Take it to number 1. Now we look for s. Here s1 is equal to h times f of x0 and y0. We consider here x0 and y0 from the starting value. Here h is equal to 0.2 into f of x0, 0, 1. If we start with 1, we take 1. If we start with 0, they may be 0. We can write them 0. So in this case, we can change like this: y0, 0, here 0, and 0. There is no difference. If we start the formula with I is equal to 1, they is equal to x1 and y1. 0.2 times here f of 0. Where is the function? Here it is the function, main function, x square minus y. We have to put this value in this function. Here x is equal to 0, y is minus 1, that is equal to minus 2. It is the value for s1. Then for s2 is equal to h times f of x0 plus h by 2, y0 plus s1 by 2. Here we put the values. H is 0.2 into f of x0. x0 is 0 plus 0.2 divided by 2, y0. y0 1 plus s1. s1 is minus 2 divided by 2. We can calculate it. That is 0.2 into f of 0.1, 1 minus 1, that is equal to 0.2 into f of 0.1, 0. Now for S3 is equal to h into f of x0 plus h by 2, y0 plus s2 divided by 2. That is equal to 0.2 into f of x0 is equal to 0 plus h 0.2 divided by 2 and y0 1 plus s2. Here S2 is equal to, if we put here the values, S2 is equal to 0.1 square minus 0, and that is equal to 0.01 into 0.2, and that's come to be 0.002. It is the value for S2. Now for S3, it is 1 plus 0.002 divided by 2. That is S3 is equal to 0.2 into f of 0.1 comma 1 plus 0.001, that is equal to 0.2 into f of 0.1 comma 1.001. Now our function was x square minus y. Here we put these values: 0.2 into 0.1 square minus 1.001, that is equal to 0.2 into minus 0.991, and that is equal to 0.2 into 0.991, that's equal to minus 0.1982. It is S3. Now we look for S4, and S4 is equal to h times f of x1 plus h plus y0 plus S3. That is h is equal to 0.2 into f of, and x0 was in starting, it was, I think it was 0 plus h 0.2 and y0 was 1 plus S3 minus 0.1982, that is equal to 0.2 into f of 0.2 comma 1 minus 0.1982, that is equal to 0.8018, that is equal to 0.2 into 0.2 square minus 0.8018, that's equal to 0.2 into 0.04 minus 0.8018, and that's going to be equal to minus 0.8018 into 0.2, that is minus 0.1524. We can round off the values up to the decimal 4th place. In this way we get all the values. Now we find the S. S is equal to 1 by 6 into S1 plus 2 times of S2 plus 2 times of S3 plus S4. We substitute all the values here, that is S is equal to 1 by 6 into, here S1 is minus 2 plus 2 times of S2 0.002 plus 2 times of S3, that is minus 0.1982 plus 2 times of S2 plus 2 times of S3 plus S4. S4 is minus 0.1524, that is equal to 1 by 6 into minus 2 plus 0.004 minus 0.3964 minus 0.1524, and that is equal to minus 0.4241 approximately. That is the value of S. Now, from where we started in the first step, that was, say, it was, I think, yi plus 1. It was the first step. Yi plus 1 is equal to yi plus S, or y1 is equal to y0 plus S, or y1 is equal to, and y0 was 1 and S is minus 0.4241. That's equal to 1 minus 0.4241 is equal to 0.5759. Now it is the first step. In the same manner, we can continue. Okay, you can make corrections. If there is some decimal problem, you can make it somewhere. Okay, I will check it. That the main purpose is you must have followed the procedure. Now here S1, it is minus 2. S1 is minus 2, not decimal 2. It is minus 2, integral value complete, minus 2. And for the next step, now we have here x1 and y1. How we will get for the next step? x1. x1 is equal to 0 plus 0.2. It was x0 plus h. That is the x1, and y1 is equal to 0.5759, and we can continue the second, third and fourth step until we get the repetition of the same value. But for exam's point of view, only one step is sufficient in the Runge-Kuttas method. It is rather lengthy, and the calculations, they are very narrow and the typicals. It requires great patience and the concentrations. These are the two main methods in the linear differential equation, Euler's methods and the Runge-Kuttas fourth method, order method, and both are frequently asked during the exams. That was somewhat about the numerical techniques or computer-oriented numerical techniques. Now we shall discuss about some statistical portion, the main statistical portion in this topic. That we start with probability. It is the probability distribution. Probability distribution. It is the advanced steps from the simple probability and the conditional probability. Here we deal with the random variables. Different names with the random variable we shall discuss one by one. First of all, let us understand what is a random variable. I think an example will be the better to understand this. In the basic probability, we always discuss if the two coins are tossed, find the probability of coming head. If the three coins are tossed, find the probability of coming head. That was the simple probability. If we change our statement in this way, if three coins are tossed simultaneously, find the probability of coming three heads. Or we can say, find the probability of coming head. When it is three heads, it is simple probability, it will be 1 by 8 in the throw of the three coins. But if we say find the probability of coming head, the number is not known. The head may be 1, head may be 2, head may be 3, or it can also happen there is no head. Here the variable has attained the different values 0, 1, 2, 3, and such a variable we say it is random variable which assumes the values according to the given event, but it is not defined, or specifically it is not defined at the certain point. Let us start with the same example which we discussed here. It is a probability distribution function we are studying. In this topic we shall discuss about the binomial, Poisson, normal distributions. They are the main important sections of this distribution.